Good morning to all of you. So happy to see all students have joined. 54 students are there, and even in the offline sometimes students will come late 5 minutes, but here before the siren 54 students are there in the class. Thank you. Let us start today's class, and now we are almost come to the end of this particular chapter. Let me revise what we have discussed in the previous class. Hope somebody might have executed ax.bar function, and these things we have discussed in the last class. X, height, width, bottom, align, the meaning of these things. I asked you people to read it, and I paused for some time in the last class. Hope even you might have done the revision. Hope some students might have executed some programs, and few students may be busy in writing your assignment also. Let me go to the next. This is another, just take a few seconds and glance those who have not gone through. So we have taken a country, we have taken a GDP per capita. So in this case, different colors we have chosen. So explicitly we have chosen a color, and we are giving that as a input, and we are getting different colors in the plot. And font size, for these things you can change and you can execute whenever you get a time. So these things we have discussed in the previous class. Let me go to the next slide. All these you have copied already, and one beside the other I want to plot like this, a bar chart. Then I have to use a plus width so that one beside another will come. This also I have copied, hardly 2-3 lines program, and hope some of you might have executed. Okay, let me know anybody has executed at least 2-3 programs. Hardly 2-3 lines are there. Let me see if somebody has executed. I will be happy to see their names. Any 2-3 programs, hardly 2-3 lines are there each program. So if you executed, well and good. Otherwise, please try to execute so that you will learn, and use the online simulator, which is very easy to do it. No need of any installation or anything. Happy to see all these students' names, those who have executed these programs, and really happy to see that you have executed. Let me go to the next. One above the other when you want to draw like this. So only the change is all these things are almost same. Bottom I am changing. Bottom equal to data 1 I am using, so that data 2 will come above the data 1. Take a 30 seconds, just glance once or twice so that you will remember, and we can continue the next. And try to prepare the report of your project. So within a few days, because all the teachers has to finalize their marks, and before they do it, you keep your PPT, final PPT, as well as your report ready, so that you will get a good marks. Let me go to the next slide. And these things I asked you people to try. I don't know anybody has tried. Nobody has emailed me. I asked you people to make use of these arguments and execute how the plot looks. That I asked you people to copy and paste in the MS Word, and also asked you to share it. But nobody has shared. I think Sindhu has shared one file, and other students, they have not done anything about this bar chart. She has said something else, but I asked her to not to modify. Time is less, lot of assignments will be there. These can be done in the free time. Manual can be prepared. But these things, for exam point of view, at least you could have executed. Anybody has executed by making use of few arguments, let me know. I'll be happy to see. Different arguments you have to use and you have to execute. If you are not done, please do it. And if time is there, I'll do it for a pie chart, and I'll show how to do it. Similarly, you can do it for a bar chart also. Let me go to the next slide. Now today, we are going to talk about a pie chart. It is straightforward to draw the pie chart. We use x dot pi we use. We are passing some array of values to this x dot pi and we'll get a pie chart. And the values will be normalized by their sum if the sum is greater than 1. So you can give a different values and observe the pie chart, you will come to know this. And labels, percentages, exploded, segments and other effects are handled with a table 7.10. These things today I am going to show you how labels can be given, how exploded can be used, etc., which is given in the 7.10 table also I will show you, and also some examples I will show you. Take a minute, just note down x dot pi, which I am going to use a function for pie charts. Many arguments may be optional, so until and unless you use, so you will not come to know what is the use of that particular arguments. Some of the things are optional, not compulsory. The way how you have seen in the bar chart, like that also we have a list in the pie chart. I will show you in the table 7.10. Let me go to the next slide. This is a syntax. Anyway, we are going to use the syntax and going to write some programs. No need to copy, just glance once. And some example we'll see. A simplest example we'll see. Then we'll try to use a different arguments and we'll see how the pie chart looks. Labels, colors, shadow, etc. Today we'll try to see in detail. Like that you have to do it for bar chart. I thought somebody will do and will share, but nobody has done. You may be busy with your other works, no problem. Let me do it for at least a pie chart. If you have done, it will be easy in the exam to write. With the result you can explain. If I do like this, it will come like this. Otherwise, simply if you read it once, it is difficult to write in the exam. So these are the common arguments to the x dot pi. Today we will try to make use of these explode, shadows, topicity, PCT distance, etc., radius. Some of these things I will try to change and we see how the pie chart looks. Just note down the at least argument, a description you can read, arguments you can note down. I'll wait for another 1 minute, 30 seconds. Colors, labels, explode, shadow, STARTANGLE, you can say start angle or whatever it is, topicity, PCT distance, label distance, radius, few will try. So the way how I am going to show you for a pie chart, do it for a bar chart. And sometimes a theory question may come. List the common arguments to the x dot pi. Explain with some examples. So that time you should be able to write these arguments and should be able to write the one example, how it looks, the pie chart you should be able to write and explain. As such theory questions may come in the exam. I'll wait for another few seconds. Just read it twice, thrice. Then we'll go to the next slide. Let me go to the next slide. A simplest program, hardly a 2-3 lines program. Y equal to np.array. I am taking 35, 25, 25, 15. You can take any. I have taken a total, I think 100. Plot the pie chart. Plot show. That's all. Take a hardly 3-line program. No need to copy the result. I want you people to execute this 3-line, 4-line program so that you feel comfortable in the programming. Y equal to np.array. I taken a 35, 25, 25. The first one is a 35, then 25, then 25, then 15. It's like anti-clockwise, huh? Don't get confused. 35, 25, 25, 15. Lot of arguments you can pass when you are writing a plot plt.py. But in this example, I have passed only the y, nothing else. A simplest program which you can execute for a pie chart. Let me go to the next slide. This a program I have taken a cars, a different name of the cars, and data I have taken, maybe a sale or something. You can take just data and cars are taken. And I am plotting the size, figure size I am taking a 2,2. The same program I am using here also, only the change I am underlining for your reference. Instead of 2 cross 2 or 2 by 2, I am using a 3 by 3. Remaining program is same, and observe the output how it looks. When size is small, the character of these things, whatever I have written, the name of the cars are a little bit large. When the size of this becomes more, what you are writing, this name of the cars, automatically it is coming, but font size looks small. I want you people to copy down this and just add 3,3 above this 2,2 so that you can execute by making a small change, and you can observe the output so that you can remember for longer time. Take a minute, another 1 minute. You can copy down any car name, whichever you like. You can write down Maruti, those whichever you want. Tata, Mahindra, all Indian, we can type, no problem. So take some data. And adding it doesn't give you the 100 now, but based on that, it will plot the pie graph. The only change I have made in between these two programs is 3, 3 I have done, here 2, 2 I have done. We can try with 4, 4 also. In the previous example, we didn't use labels. Simply you have passed the data. Now, one extra, what I am arguing passing is the labels. So, way how you have to make changes in the program, you should execute. These are all not from the textbook. That's the reason I am asking you to copy down, so that you can execute. Let us go to the next slide. Now, it is our same program. is only instead of sending y argument, I am using this auto pct, a percentage d, whatever the content data I have given, all these things will come. I think 35, 25, 25, 15 should come. I don't know why this is a 34 it's showing. While executing I might have made something. Just this is the way how it will display. That much you should note down. Only one line extra, auto pct, percentage d I am passing. So these will come in the pie chart. That's all. Take a few seconds and note down only this plt.py y comma auto pct equal to, so that these will come and these will be a part of your pie chart. Let me go to the next. If sometimes instead of a integer, if you are having a float, instead of a percentage d, we are using a percentage f. Just glance once, and we will see. Again, question may come. This is figure dot add axis 0011. We have already discussed. Again, we'll see some examples. The figure size I had taken a 3,3, and you can change and you can execute. And it is very difficult to make use of all the arguments one by one, executing that and copying those program, copying all those in the results in the PPT. If you do, it will take more time, not only for the preparation, even to cover all those things in the class. I want you people to do it so that it will be easy for you to understand. Say for example, so now program is same, only what I am passing is labels. Along with that, start angle I am passing. The start angle I have taken as a 90. How it looks? So this is a 90 degree. Let me take a start angle as a 120, and how it looks. Instead of this 90, it will become 120. Observe it carefully. And instead of 1, only this I am changing in the program, nothing else, a same program. Start angle I am changing from 90 to 120. Now I am changing the start angle from 120, instead of that I am putting a 180. Next time I am putting a start angle equal to 250. How the pie chart looks, you are going to see now. And all program remains same, only this I am changing. Hope all of you can understand. Let me show you the start angle when it is a 180. So this is a 180, and this is a 90, and this is a 120. Similarly, let me show you if a start angle, if I make a 250, I am not changing any program. Only this I am changing, and I am observing the output. Can you say how many times minimum I have to execute this program to prepare a slide? You want to prepare this slide, how many times you have to execute a program? Hope all of you have 4 times I had to execute a minimum. And I had to copy paste those results in the PPT. I had to reshape, I had to position, I had to type the text. Hope all of you can understand how much time we take to prepare a one slide. So to convince you people, and convincing is not an easy job. During your seminar you will come to know this. Convincing is not easy. So hope all of you are doing a seminar or your presentation, project presentation, you may give to your guide now, because they have to finalize the marks. Keep your all presentation ready and your reports ready so that I can do the submission. Okay, let me go to the just go through. You can copy down at least one line. plt.py y comma labels equal to my labels comma start angle equal to 90. There only you put underline, put a different 120, 180, 250, etc. And try to complete the assignment. Today afternoon you will be free, tomorrow you will be free, so that you will get a time to write. Make a 2 separate PDF file with your USN number, name as assignment number 1 and assignment number 2 should be a part of your file name, so that whenever we see it will be easy for us to recognize this file belongs to this particular student. Let me go to the next slide. Yeah. Now, a program is very simple, you can understand. Only I am concentrating on one statement. So these are the labels, these are the sizes, some data I have taken, and colors you can choose whichever you want, using a RGB combination and using a hex values, and all of you know this figure.ax. I don't want to explain all these things. Only I'll concentrate on only this. Explode 0.100. When I give this 0.1, you observe this. It will come out like the way how you cut the pizza or something like that. So this is a way how I can use a explode. No doubt I'll show you a few more examples. In the previous program only you can just copy down explode 0, 0.1, 0, 0 if the 4 are there data. 5 are there, add extra one more 0. Or if you want you can copy down this program only. I'll give the 2 minutes, another 1 minute 30 seconds you have. Or you can just copy down explode 0, 0.1, 0, 0 for the previous program only. Just the number of what you have used data should be equal to this explode content, what zeros and 0.1 you are writing. The colors I am choosing here, and explode equal to explode. Instead of here you can pass it here only, but I am writing and then I am passing, so that only I will change this in the next time when I am executing a program. Let me wait for another 30 seconds. And you may get here and there some doubts. I want you people to execute it, change it, execute it, so that you can observe the result easily and you'll understand. Here you can observe, anyway I'll show you, shadow is true here, therefore you will come to know here the shadow is there. For that another program, the same program what you have discussed, just I'll put a shadow equal to true, I'll show you that also. But now I'm only concentrating on this explode 0.100. Which one is the first one here? Is it first one is 10%, 15% drawn, 30% or 45%? Which one is started first? Lakshmi Priya has typed. Thank you, Lakshmi. Okay, Jyoti, Aishwarya, Nidhi, Bibi Mariam, everybody is typing. 15 is first. Second is I have a 30%, and third is a 45, and fourth is a 10. So these are the, hope all of you are remembering. Let me go to the another slide. There I have changed only a same program. I am not showing you the program. If you want, you can see. Instead of this explode equal to 0, 0.100, just I am changing these combinations, and how the pie chart looks I am going to show you now. Observe carefully this program. Only I am going to change this, and I will show you this one line in the next slide. What I have changed, explode 0.200. Earlier it was 0.1, you can see the distance. Now it is a 0.2. Now 0.3. See the 0.3. See the distance, how much it is. Similarly, third one I am taking 0.1, 0.1. So when I do the 0.1, this is becomes a 0.1. This is a 0.1, already has come again 0.1. For everything I am using a 0.1 other than last 10%. So this is a way how we can make use of a explode. I want you people to copy down this explode 0.2, 0.3, these three. Observe it how it looks. Using your own sentences for your reference, write a line or two in your notebook. Try to execute the programs today and tomorrow as you have time, and parallelly assignments might be given by the faculties, so please try to complete that also. And I will after this slide I'll try to pause, and I'll give time for you to ask if you have any doubts or related to assignment or anything. Okay. So let me pause for a minute. Now, only one parameter I have changed. This to PCT percentage D we have seen already. And here I have taken shadow equal to true. Observe this. You will find this shadow. And one more parameter just I wanted to show you people. Here, along with this shadow true, I used PCT distance 0.3. So what you are writing now, I think by default it is 0.6. It will take a distance. If you take from here to here, it is a 1. At 0.6 it will usually write by default. No sir, I don't want to write at 0.6. I want to change it 0.1, 0.2, 0.3. You can write down PCT distance, whatever you want, write down distance in between 0 to 1. So based on that, you see the difference. So here it is at 0.6, here it is at 0.3. You can change it. So I'll wait for 1 minute. So please copy down these 2-3 lines. PCT distance equal to, you can write down 0.3, 0.4, 0.5, 0.7. I think by default it's a 0.6. You can observe that also. And try to execute these programs so that you will understand and you will remember. I'll wait for another 5 to 10 seconds. Let me go to the next slide. Another important is I can change the radius. So radius I have made here 0.5. It will become a small or a half, and by default radius it will take is a 1, but I have made it as a 1.5 radius. Observe the difference. This is 0.5. This is 1.5. Previous slide, I have not done anything, but by default, it is a 1. This is a difference when you don't give radius equal to anything, and you can give a 0.5, 1.5, so that the radius will change. I'll wait for a minute. So copy down there only. Another parameter what you can send or you can pass is a radius equal to 0.5, 0.6, 0.7 or 1.2, 1.3, so that the size of this chart will change. And after this also you can make changes in that position. Instead of 0.6 by default, you can change it. Let me wait for another 5-10 seconds, then we'll go to the next. You can observe here, for every slide, program I am executing more than once or twice. Not only executing, I am copying all those, I am pasting, I am again aligning and rearranging for each slide. I could have told orally, but I believe a picture tells 1,000 words. A few of the students, they changed their slides when they were giving the presentation last time. When our students, seniors, they told them they did a fantastic presentation, and they didn't share that PPT, both the PPTs to us, even though I told. Anyway, we'll see it later. Let me go to the next slide. So these are the what we have discussed, a few common arguments to x.py. I want you people to go through once. If one or two remaining, if we have not yet discussed, please do it and observe the output. Take a minute, go through, read it once. I'm sure now when you are reading, description will give the more meaning now compared to the previous. Thank you, Sindhu. I'll wait for another few seconds. Go through the description also now. Read the argument, go through the description and understand radius, PCT distance, start angle, autopacity, shadow, explode, etc. Colors also you can assign. Hope all of you have understood most of the arguments given to the x.py. I expected you people to do like this for a bar chart and share, but nobody did it. You people may be very busy. No problem. For pie chart I did it. I'm happy that I have learnt and I shared with you people. Let me go to the next slide. Now last bit of this unit, multiple subplots. So what we use to create a figure with more than one subplot, simply we call add subplot, and on your figure object setting its argument to indicate where the subplot should be placed. We will see the one or two examples how add subplot can be used in our program. When to use also you'll come to know. We'll see some examples. And subplot number increases along the column in each row and then down the rows. If you understand well and good the second line, no problem, we will see examples only, because picture tells 1,000 words, sentence may give a small information. But read it, we cannot directly go to the diagram or with the example. A theory we have to tell you. There's a reason I'm spending a little time on this particular slide, another few seconds, then we'll go to the next slide. I'm taking a hardly 2-3 line program so that everybody can understand. A figure equal to plt.figure. What I use is add subplot 3 2 1. It's a top left subplot. So 3 comma 2, 3 rows, 2 columns. First one it is added. Just copy down one line, ax1 equal to, or 2 line you can copy down, remaining will become easy. Just I have copied and pasted. Instead of only 3 2 1, I am adding a 3 2 2 something. Just I am changing a one position and I am just checking how output looks in the next slide. Let me go to the next. Anyway, the same program will be there. It is not a top left subplot, but just I have copied and pasted. Only instead of 1 I have done now 2. Just how it looks you can see. 3 2 2 it becomes a second. This is the first, this becomes a second. And let me go to the next. I am using instead of 1 2, now I am using a 3 and 4. This becomes a 1 2, this becomes 3, this becomes a 4. I want you people to copy down. Instead of ax1, I want you people to take ax2, ax3, ax4. So that whenever I am accessing, so I will make use of a different subplot. I should not give the same name. I given, let me see how you copy. And these are just copy and paste it. It's not a top left subplot everywhere. Just have copied and pasted. Just this I have changed. That's all. You don't copy top left subplot for everywhere. Only it was for the first one. Now let me go to the next slide. So this is a way a complete program written. X1 equal to X2 equal to 3 to 1, 3 to 2, 3 to 3, 3 to 4, 3 to 5, 3 to 6, X1 to X6. I'm just showing it. Now this is a complete program. If you already copied something wrong, make changes and copy down the complete program now. 3 to 1 up to 3 to 6. How we can have a subplot. Let me go to the next, hoping all of you have completed this. Alternatively, to create a figure and add all its subplots to it at the same time. I don't want to write so many sentences, sir. Ax1 equal to x2 equal to so many times. I want to write only one. Then you can use a plt dot subplots. And how to do it, I'll show you in the next slide. And which will take us some arguments. Those arguments details are given. Just go through this particular slide. I'll give you the 1 minute. Read it. How to use a plt dot subplots. We'll see with the example in the next slide. A figure size, and I told DPI. Hope you people can recall DPI. Oh, it is here only, dots per inch. You can recall, we have discussed once, face color, edge color. So we have, these are the arguments for figure. Let me go to the next. We have already seen 7.1. So this is a program. Execute it. In a one line I can write n rows equal to 3 or a number of columns equal to 2. Simply within a one line I can complete. There are taken x1, x2, x3 equal to. And now I am taking one line program to get this. Just copy down a figure comma axis equal to plt dot subplots. Yes is important, don't write a plot. It's a plots. You're passing number of rows equal to number of columns equal to. You can observe the previous if you already copied. It's not a plots, it was a different, and now I'm passing these things. And print axis dot shape. After this, how many row column are there? Just it is printing 3 rows and 2 columns, that's all. And you can assign ax1 equal to what, ax2 equal to what, so that you can plot in particular subplot. Let me go to the next slide. Otherwise, I'll wait for another 10-20 seconds. I want you people to copy down at least one line. Figure comma axis equal to how we can create subplots using one line. Okay, let me go to the next slide. In fact, a useful item to create a plot with a single axis. You can use simply subplots, but don't give any arguments at all. This is one way how in most of the programs you may find. So we have a few more examples. So x equal to np line space 0 2. I hope all of you know pi. 2 pi means how much it will come around approximately. All of you know pi value into 2. So I think 6 point something you will get. And 400 I am taking total line space. And simply I am writing a sine x square. And that I am plotting it. This is a way how we can do a vertically stacked subplots. It is possible to do it horizontally also, that we'll see it. There what I am passing here, subplots, here what I am passing will be different. So that is I am sending a x comma y and there is x comma minus y. So you can observe carefully the phase shift is there. Observe these two carefully and try to copy down this program, because next slide also we have a same program, almost a small change in the program. That time instead of copying complete program, whatever change is there, just underline and write something above that so that you can execute 2 programs. Let me go to the next slide. Yeah, vertically stacked. What is the difference compared to the previous and this? Can you observe and type your answer in the chat box? I'll wait for 30 seconds. I'm sure at least a few of my students will write. Thank you, Jyoti. She could be able to find out even underlined, yeah, so that your concentration will go there only, where definitely you will see that only. It's a 4 pi. Earlier it was a 2 pi. Now it is a 4 pi. Therefore, 4 pi, 4 into 3 approximately it will come above the 12. That's the reason you are getting this. Previously it was a 2 pi. There's only one changes are made, nothing has changed. No need to copy down the whole program. Underline that below or above that line. Copy down a 4 pi. That's all. I'll wait for another few seconds, then I'll go to the next slide. Let me go to the next slide. Now, what changes are there? You can observe and copy down only that. In this program, compared to the first program, there also I have taken 2 pi, here also I have taken 2 pi. What are the differences are there? You can type in the chat box, observe it carefully. And those changes you can make. Thank you, Shiva, Jyoti. 1,2 we have written. There it was different. Now it is a 1,2 we have made. And another change is Anything changes there in the compared to the first program and this program? 1 comma 2 is correct, Naina. And Parvati Devi, thank you. It is a horizontal. Previously, the subtitle we have given as a vertically stacked subplot, and now it is a horizontally stacked. Thank you. Hope all of you have understood this. Let me go to the next. Thank you, Arfali. The same thing I am using now. Subplots I am taking 2 comma 2. Hope all of you will come to know how many plots I will get. And each plot I am plotting the same thing. X and Y only I am plotting, but only the change is colors I am changing. First one is the orange, second is the green, third is the red. Like that I am changing the colors, and you can observe the output. I want you people to take a minute or two, copy down this, because these are not from the book. Just I am downloading, I am copying, I am writing, and I am editing, and I am executing, I am sharing with you the program typed. By saying these colors only you'll come to know this is not from the textbook. It is from the simulator. After executing I am copying. That's the reason colors will change. Otherwise everything would have become a black. There would not have been any tab here. All programs I have typed and I have executed, and those only I am sharing with you people. And to execute this, I am taking a time. I am spending my time so that I can understand and I can share with my students. Now, just I am in this particular program, I am concentrating only on subplot. 2 comma 2 means what? If I change the color, how it looks, so that I can show you how the plot looks. I'll show you, observing only these things. So this is how the result looks. The colors have changed. In some cases I have given the X, in some case Y, in some case minus Y I have changed. So based on that there is a phase shift that you can observe. And because I changed the colors have changed. And you people can execute these programs and try to understand. Let me go back to the program. This is a program, and different colors I have chosen, and these are the different colors. And the last is multiple subplots. I think we are completed now. This completes your unit 4. So next class we will start unit 5, and now tomorrow and today you have time to execute all the programs. Thank you. See you in the next class. And if you want to talk to me, I'll be here for another few minutes. Take care. Bye. See you in the next class. Thank you.